It's finally the moment that many of us have been waiting for. Welcome, one and all, to the 6th edition of Big Data Europe. I'm Darren Elmy, your ever faithful host and companion, and I'm here to guide you through all the happenings in the next 2 days. 2 days that will be brimmed full of invoking sessions that we've put together with a bunch of industry professionals here. In fact, if you have a passing interest in big data, machine learning, or AI, you're definitely going to want to bookmark each of these sessions. And well, with 1,720 registrations for this event alone, I'm sure there's going to be a lot of networking going on, as well as a lot of interactions with our Q&A sections. Seriously, guys, 1,720 registrations. That is impressive. And of course, there's plenty of discussions going on. Today alone, we are going to have 21 deep discussions for you, conducted by known and recognizable industry experts in their fields. So make sure that you've either got a few monitors plugged in to catch all the action, or carve out some time in the coming weeks to catch up on all the sessions that you aren't able to live. And before we do start, I've got to give a big shout out to our sponsors, without whom this wouldn't even be possible. First of all, our platinum sponsor, Telia, a telecoms communication company that services over 25 million customers across the Nordic and Baltic regions with both digital infrastructure and services. Amazing work they do. And of course, our gold sponsor, Amplitude, a digital analytics platform that gives self-service visibility into the customer's journey from start to finish. And rounding out, of course, there is Essentia, a global professional services company with leading capabilities in digital, cloud, and security services. And I would be remiss if I didn't mention free stuff. That's right. I love that word whenever I'm at an event. So if you want to grab yourself some free stuff, we have partnered with Manning Company. They are going to award the most active conference attendees with free ebooks. How do you show your activity? Make sure that you comment and rate each of these sessions to stand a chance on winning yourself some valuable books. But I won't keep us any longer. It's time to kick off the day. And what a way to do it. We're going to do it with one of our keynote speakers. We invited Steve Upton, who is the lead QA consultant over at ThoughtWorks, to quite fittingly talk us through why we are overthinking data quality. Steve, take it away.
Thank you so much for that lovely introduction, Darren. Hopefully you all can see my screen and see and hear me. As mentioned, I am a QA consultant at ThoughtWorks. ThoughtWorks is a global technology consultancy. So if you ever want to work with some lovely, clever people, come and say hi. And over the last couple of years of my time at ThoughtWorks, I have been working in some pretty big data engineering projects. Some pretty big data engineering and data mesh projects. And one of the things I found is that people seem to struggle with this idea of data quality. I'm technically a QA consultant, and lots of people come up to me and they say, what is data quality actually? How do we measure this? How do we work with this? There seems to be a lot of confusion about this. And I think that it's largely because of this. We've all seen errors like this, right? We've gone to a website, we've gone to an application, we've looked at something and we've seen an error. It didn't work. We tried to do something and it didn't work. What's up with that? See, anyone can look at this page and see that something's wrong. Anyone can look at this page and see that there is a problem. There is a quality problem here because I can't do what I want to, right? If I go to an online store and I try to buy something, and I can't buy it, well, I can't. That's failing the sort of the main mission of that online store. There's a clear functional failing there. There are clear functional requirements, and obviously there's more to quality than that. But pretty much anyone can pull out at least some fairly obvious problems when we're thinking about testing and building and the quality of the things that we're building. But that isn't necessarily true with data. Are there quality problems with this data? That's a much harder question. Where's the quality here? Can we even talk about quality in the same way? And there's certainly a lot of stuff that's been written about data quality. There's data quality management frameworks and tooling and libraries and platforms. Lots and lots of stuff has been written and built around data quality, but I still see a lot of questions and confusion. And despite that, I just kind of think that for all of the questions and the confusion there, I just think you're overthinking data quality a little bit. But with that said, I do want to sort of put all my cards on the table here and be honest. There are some difficult things here. Okay, there are some genuine challenges when we're thinking about quality and testing in the context of data. And I think one of the first challenges that we have when we're working with data quality is related to the Oracle problem. Maybe you know the Oracle problem. It's not related to the software company Oracle. That's a different problem. But the Oracle problem is well, it refers to these oracles here. So this is the oracle at Delphi here, and the oracles were sort of mystical Greek ladies who were locked in temples. And there's already quite a lot to unpack there, but people would go up to the oracle and they would ask them questions. They would ask them questions like, "What's the weather going to be like next week?" Or "What is our harvest going to be like this year?" Or "If we go to war, will we win?" Because the oracle, this is again the oracle at Delphi here, had the power of foresight. They could see the future. So they could give the correct answers to those questions. And knowing if you're going to win, if you go to war, is actually quite a useful insight to have if you're thinking about, going to war. The oracle problem, though, refers to the fact that oracles don't exist. They're not real. I mean, obviously there were Greek ladies locked in temples, sure, but they didn't actually have the ability to see the future. Where this is relevant to software engineering, because the Oracle problem is a software engineering problem, not specific to data, is in this line of code here. So I'm assuming everyone has written a line of code like this, possibly this exact line, at some point or another, right? This is part of a test, and we are asserting that the result we got, the actual result, is exactly the same as what we expected to get, right? So we run the test, we get some output, and then I say, okay, I want to make sure that the output is what I expected to see. And if it isn't, the test fails. Right? I'm sure you've all seen and probably written a line of code just like this. The problem is, in order to know what we expect, we need an oracle. We need what's known as a test oracle. A test oracle is something that gives us the correct answers, the correct behavior of the system. The problem is, we don't always have a test oracle. Imagine this test here, right? Imagine I'm setting up a shopping cart, right? So I'm testing some sort of e-commerce, some sort of online shopping site, right? So I create a new shopping cart. I add a test item to that shopping cart, and then I assert that the size of the cart is equal to 1, right? If I add one item to the cart, there should be one item in it. That's easy, right? This is not a problem, right? This is not really, like, I don't need a test oracle here. Like, I can just look at this and figure this one out. But here's where it gets a little bit more difficult. Let's say I'm multiplying two floating point numbers. What's the correct answer here? See, the answer I get might depend on the hardware I'm using, the platform, the library, the framework, the precision, even if you're using certain very old Intel CPUs, could give you different answers to other ones. Floating point maths exists to annoy software engineers. And depending on the setup, depending on everything that is leading up to this point, that I could get different but equally valid answers. There isn't one simple expected answer. And there is not a test oracle that I can ask. Tell me the correct answer. The correct answer doesn't really exist here. And that's a problem. That's the oracle problem. And things get even more challenging when we're dealing with things like machine learning models. What if we're making a prediction, for example? I train a machine learning model to predict the amount of sales I'm going to get in the next month. Okay, what is the correct number of sales for the next month? If I knew the answer, if I knew how many sales I was going to get next month, I wouldn't need to build this model, would I? The reason I'm building this model is because I don't know the future. So this is the oracle problem here. We don't always know what to validate against. We can't always give a simple, this is the correct answer, fail if you don't get the correct answer. The oracle problem is always a problem in software engineering. It's one of the oldest problems in software engineering, but it really comes front and center when we're talking when we're working in the data space. Now, another problem, and this isn't explicitly related to the oracle problem, but very often if I'm processing some data, let's say I'm processing tens of thousands of records, or millions of records, gigabytes and gigabytes of data, the actual result I'm getting could be pretty big. And comparing those and actually generating 10 gigabytes or multiple gigabytes, even terabytes of expected data to validate my pipeline running against is a non-trivial exercise. I mean, the comparison is sure like that's computationally easy enough, but actually creating this data is pretty hard. So we have two pretty big problems when we're working with data, two pretty big challenges when we're thinking about how we test our data. The first is we don't know what to expect. Sometimes we do, sure. But very often we are dealing with uncertainty. We're dealing with unpredictable answers, with probabilistic answers. So we don't always know what to expect. And even if we did know, the answer would be too big to meaningfully compare or to meaningfully do comparisons on. So I want to deal with these two in turn here. One of the look at the first is how do we deal with the oracle problem? So I mentioned that the oracle problem is one of the older problems in software engineering. It's not a new thing. It's not specific to data. And it's related to this line of code, right? I am running a test and I am asserting that the thing I get is equal to what I expected to get. This is the problem line of code here. And this is an example of what we call example-based testing. When you run a test like this, what you're doing is you're giving the computer, you're giving the test an example of how the system should work. And if it doesn't work that way, the test is a failure. If it does work that way, if it follows the example as you expect, it's a success. This is what is known as example-based testing. But this is not the only way of writing tests. There are other approaches here. And one of those other approaches is what's known as property-based testing. What we do with property-based testing is a little bit different. First, we generate a whole bunch of test inputs of potential things that we could put into the system, right? Then we put that into the system, right? We have a system, a function, a thing that we are testing, and we put the data into it. And then, rather than checking against specific expected values, we assert that every result has certain properties. So we're looking here at the shape, how the results look, rather than specific expectations. So let's give an example here. Let's say I am testing the classic string concat, right? So I've got two strings and I want to concatenate them. I want to stick them together, string one, string two. Okay, so I can generate a whole bunch of strings that I want to put into this, right? Random strings. This is easy to do. Technically, there would be two lists, one for string 2, or you would have combinations, but you generate lots and lots of data that you can put into this function that we're testing. And then we run all of these inputs through the function that we're testing. And then we make assertions on the answers. So we say, okay, whatever result I get, it should be a string, right? That one seems pretty easy, doesn't it? I mean, yeah, if I'm concatenating two strings, I expect to get a string out of that. That's easy. Whatever the result is, its length should be equal to the length of the two strings that I created, that were concatenated together. Okay, that's easy, right? I'm also going to assert that the result should include all of string 1, and that it should include all of string 2. And this isn't an exhaustive list, right? There's more that we need to add here, certainly. But here we're looking at the properties of the results. So we're not running specific examples. We're running lots of things through the system that we're testing, through the function in this case, and we're looking at the shape of the data, the properties of the results. And I'm sure some of you are looking at this and thinking, Steve, That's exactly what Great Expectations does. Great Expectations is a lovely little data quality library framework that does exactly this. Right? It's intended to be plugged into and sort of wired into your data pipelines and provide these sorts of assertions, these sorts of property tests. So here's an example of what it looks like. I just pulled this from their documentation. So they're saying here that for this particular field, let's pick up date time, all values must be between 1 and 6. Right? So that's a property of the result. It's not a specific example. We're not saying if I put in this data, this is exactly what the result should be. I'm saying whatever data I put in, the result needs to be between 1 and 6. And you'll see here it's saying, okay, 15.79% of the results is actually not in that range. So that's a problem. And we've got this other one down here saying that trip distance must never be null, and that's fine, right? Everything is not null. So here we're looking again at the properties of the results. And this allows us to avoid not having a perfect, like we don't have a perfect test oracle. We don't know what every single value in this pipeline, in the results of this pipeline run should be, but we're still able to build some confidence that the pipeline ran correctly, that it processed the data in the way that we expect by looking at these sorts of approaches. And when I first heard about Great Expectations, when I first started using it a couple of years ago, I dug into the documentation and I searched for property-based testing. And I found 0 results, which is kind of interesting because this is property-based testing. We're running lots of inputs through and we're checking the properties of the results. So why didn't I get any results here? The reason is this isn't called property-based testing here. Here we call it data profiling. I'm sure some of you are yelling at the screen. That's data profiling, Steve. It's not property-based testing. And I find this really interesting because we have the exact same idea, the same core idea, but with completely different names in different contexts. And this makes me think about pandas. Not the Python library pandas, but actual pandas. The thing I find really interesting about pandas is that they have thumbs. Right? We've all got thumbs. Most of you, I assume, have thumbs. And this panda here, you can see, is holding this tasty piece of bamboo here, and they're holding it with a thumb. What's interesting about this is that most animals do not have thumbs. Thumbs are quite rare in the animal world, right? Some of our very close evolutionary cousins, the chimpanzees and bonobos, have thumbs, but most animals don't. In fact, if we look at this evolutionary tree, this sort of phylogenetic tree here, you can see sort of how long ago we separated from pandas, and yet they still have thumbs. So you see here, humans and mice, we split apart in evolutionary terms about 73 million years ago. And polar bears, pandas, we split away from them about 85 million years ago. Most of these animals, dogs and tigers, do not have thumbs, but pandas do. That's really interesting. Even though we're very, very far away in terms of evolution, and they're not exactly close cousins for us, they still have thumbs. That's interesting. And if we actually look at the thumbs, we'll see that they're actually very different to ours. They're not exactly sticky, outy thumbs like ours. They're more kind of little nubs, right? They sort of don't quite work in the same way, but they're still arguably thumbs. This particular diagram here puts thumbs in quotes, which it's like thumb, which I think is a little bit rude to the pandas, but okay, whatever. And yet they have thumbs. Here is a panda eating some tasty bamboo, gripping it with their thumb, the panda's thumb. See, this is an example of what we call convergent evolution. The same idea, the same concept, in this case, thumbs, has evolved in different places. It evolved separately, it evolved independently, it evolved in different contexts, which is why our thumbs and pandas' thumbs look so different. But it turns out being able to grip things is useful. So it evolved multiple times. Thumbs, they're great, right? They allow us to catch cabs. Pandas can catch cabs in ways that no other animals can. And this is exactly what's happened here as well. The same idea of not testing specific examples, but looking at the shape of the results, the shape of the data, the properties of the results, is a useful idea. It's something that has independently evolved in different contexts. It's evolved in the field of data engineering, and it's evolved in the field of software engineering. They've evolved in slightly different ways, and they have different titles for them, but it is the same idea. And this is a challenge that I see for a lot of people, particularly moving into the data space, is they need to learn new words for things. We need to understand that very often the idea, that the tool, the feature we're looking for, it does exist, but it might have a different name, or it might work in a subtly different way because it evolved in a different context. This is a challenge that I think all of us working in our fields need to deal with, particularly if we're sort of transitioning into the data space. So you do need some example-based testing, right? You should write unit tests. If you can break your code into units, you should write unit tests. And sometimes you do need to write small examples for that. But sometimes you need to rely on data profiling, on property-based testing, looking at the shape of the results instead. But we still have this second problem, right? Which is, even if we did know our answers, even if we did know exactly what to expect, the answer would be way too big. And I actually don't have the chat open, but I'm assuming you're all yelling at the screen. You're saying, Steve, we have the answer to this one. We just generate some fake data, right? Yeah. Stop handcrafting your test data, right? Creating 10 gigabytes of handcrafted expectations is not practical in any way, right? And we have tools to help us with this. Just Google fake data generator, right? If you want multiple gigabytes of fake names, email addresses, IP addresses, whatever you want, you can do that very, very easily. Outside of small examples, you probably should not be handcrafting your test data. So this one seems kind of easy, right? This is a nice solved problem. We have tools that can generate fake data. We can run those through, and that's going to be useful for our testing and our validation and our QA purposes. But I want to throw a little sort of spanner into the works here, a sort of wrench into the works. The data we use to train our models, the data we use to validate and evaluate and test our models, impacts how well they work, impacts where they get things wrong. Now, at this point, I am legally required to quote George Box, and I'm sure you all know the quote that's coming, so just, sit down, enjoy it. George Box, a lovely English statistician here, is talking about statistical models of the world. He pointed out that all models are trying to describe reality, but they will never describe reality perfectly, because all models are approximations. They're just approximating reality, which means all models ultimately are wrong. No model is going to get everything perfect. There are going to be exceptions. There are going to be outliers. There are going to be things where the model gives the wrong answer. That doesn't mean they're useless. Models can be wrong and still be useful. I was looking at a news website a few days ago, and it was throwing up some recommendations to me, telling me, hey, here's the next article you should read. And you know what? Some of them were things I didn't care about. The model was wrong. It didn't fully understand. It didn't fully model my view on the world. But it did actually throw me a few useful recommendations. Things can be wrong, but still be useful. There will always be wrong answers, but I think the question we need to ask ourselves here is, who is the model wrong for? I'm sure you've all seen visualizations like this. On the left here, we have inputs, the red dots and the blue dots. And then we have different approaches to modeling this space. This is the inputs, and this is essentially the classification or the categorization and the outputs. What we want is we want to categorize all of the red dots as red and all of the blue dots in the blue area. That's the ideal outcome. And you can see here that these different approaches, decision trees, random forest, AdaBoost, have different approaches, and they give different degrees of accuracy. They're all trying to classify everything properly, but they don't always succeed. All models are wrong, but as you can see, by and large, their scores are relatively high. The question I think we need to ask ourselves is, when we see, like over here, we see a blue dots or multiple blue dots in this red zone. So these blue dots here have been categorized in the wrong way. Who are they? What is the impact that misclassification is having on them? Is this me asking, does this person care about a particular news story? Or are these blue dots people being rejected for loans? People being rejected for visas? Who are those blue dots? Our choice of training and testing and validation data impacts who those dots are. Fake data can be fantastic for catching the sort of center of the bell curve, the center of that normal distribution, but it can be very, very bad at catching those tails, those long tails, those exceptions, those outliers. You can generate lots of fake data very easily. But are you generating fake data for people who don't have a fixed address? For people who don't have a listed nationality? For people who don't know their date of birth even? Who are we excluding when we generate this fake data? Fake data, auto-generating this data, is realistically a necessary evil. It's something we need to do as part of our jobs, but we also need to understand the real-world implications on human beings here. Often the decisions, the models we are building are leading to real, impactful decisions on people's lives, and we need to understand that. We need to take that into our thought process. There are some real challenges when we're thinking about testing and working with data and data quality. But despite all of that, honestly, I still kind of think you're overthinking data quality. See, I mentioned I've been in the data space for a while now, and a lot of people come up to me and they ask the question, or they say, we have data quality problems. Steve, you've got quality in your job title. Can you help us with these data quality problems that we are having? So I say, okay. And they roll out some data. They show me this, right? Maybe you've seen something like this. Okay, so we've got some users. Okay, we've got, looks like there's a name, there's an address. What type of user are they, free or paid? How many orders have they made? And their join date, right? I can see, okay, that looks pretty good. And then I'm looking at this. Okay, I don't think A and B are real names and addresses. These are just blank strings. These are all nulls. Something's up there, right? And they look at this and they say, Steve, we have data quality problems. Can you help us with this? Can you help us work with this? And I don't necessarily agree that this is a data quality problem. We are currently 30 minutes into a talk about data quality, and we have not asked the main question yet, have we? Which is, what is quality? I can't see the chat. You're welcome to put your own answers in the chat if you want. I ask this question every single time I am interviewing a QA. What is quality? Because I don't think that there's one perfect answer, honestly. There's a few answers I don't like, and there's plenty of answers I do like. I would happily give a several paragraph answer if you let me. But there is an answer I do quite like. And it's from this guy. It's Jerry Weinberg, the patron saint of software consultants everywhere. And he put it very simply. He said, quality is meeting some person's needs. I like this definition, right? I like this because it does two things. First of all, it focuses on the actual needs. Are you actually solving someone's problem? Are you delighting someone? Are you making their life a little bit better? It's not about checking off requirements. It's not about having zero bugs. Are you actually solving someone's problems, meeting their needs? And also, it emphasizes that it's some person's needs. Quality is not an abstract thing. It is relative to a person. I would argue that the perfect app, an app that solves everyone's problems that nobody is using or that's sitting on your laptop or a staging environment, is fundamentally not a quality piece of software. Quality is about whether or not we're actually meeting someone's needs. I like this. This doesn't answer all of our questions. There's more questions to ask here, certainly, but I like this as a high-level kind of guiding principle when we're thinking about quality. So this brings us back here. Do we have a quality problem here? Well, it depends on the user, doesn't it? If I am looking at this data, and all I want to do with this data is count the total number of orders, this might be totally fine, right? Because clearly there's 3 fake or somehow invalid accounts down here, but they have 0 orders, so it doesn't matter, right? If all I want to do, the only insight I want to get out of this data analysis is how many orders in total have been made, or how are those orders distributed around various users, this is totally fine, or it could be totally fine. Now, if I'm trying to generate print out addresses for a mailing campaign, this could be a problem. What happens if I print out BBBBB on an address label, or nulls or empty strings? That could cause some problems. So depending on the actual user here, we have different definitions of quality. Quality is meeting some users' needs. So what we need to do is we need to understand our users. And this is sometimes a challenge. See, the way I think about it, we've got us, right? Ourselves, right? This is our team, the team building the thing, whether it's a data pipeline, a machine learning model. We've got us, right? This is our team. And then we've got our user over here. And we often have layers in between them, right? Very often you've got a PO, right? The PO is the person who talks to the user. They go out there. They're the person who translates those user needs to the actual something you can actually build. And very often you have a lot more layers in between as well, right? Before you have that impact, you are going through multiple systems, multiple people, multiple committees. Maybe you get into a report. Maybe there's a delay before finally, ultimately, you have an impact on a real human being. We call this intermediation. There are layers of intermediaries between us and the impact we're trying to have, the people whose lives we're trying to improve. This is a problem. Because every time we go through one of those layers, the message gets warped a little bit. There's a delay, there's a handover, there's a loss, right? Handovers are a key lean waste, if you're familiar with lean manufacturing and lean engineering. So what do we do here, right? We need to get rid, as much as we can, we need to try and get rid of this intermediation. The word for this is we disintermediate. Remove, as far as possible, remove those layers of intermediation. Go and talk to your users, if you can. This isn't always possible. Sometimes your users are literally regulatory agencies. There may be legal reasons you are not allowed to go and talk to the auditor in a regulatory agency. Fine. Your users might be end users who, again, go through some of these systems. There is no one-size-fits-all solution to how to disintermediate, how to remove those layers. But try to do it as much as possible. Try to get as close to the user, as close to the real impact you are trying to have here. There's a manifesto I quite like. It mentioned that there's a line in there about customer collaboration over contract negotiation. This is what it's talking about. This is exactly what the Agile Manifesto is talking about. Work with your customers as closely as you can. once you've found those customers, or at least someone who's close to them, someone who can really understand how they are working, what do you do then? How do you understand their needs? So I mentioned that ThoughtWorks is a global technology consultancy. We've been really active in the sort of growth of agile, sort of DevOps movements, continuous delivery. And there's an advanced agile consulting technique that we use at ThoughtWorks, and it's called talking to people. This, by the way, is a ThoughtWorks office. You can tell because almost all of the walls are post-it notes. Seriously, go and talk to your users. If you can get hold of your users, or at least someone close to them, at least someone who understands how they're actually using this data, how they're actually using these insights, what decisions they're making, go and talk to them. There are lots of questions we can ask here. We could ask them, how often is this going to be used? If I provide you with this data, with this insight, with this answer, how often are you going to be accessing this? The answer might be literally every second. I've worked on real-time alerting systems where the data is literally being polled every single second, or multiple times a second in some cases. Or the answer might be once a week or once a day. I asked this question once to a particular team. I said, okay, if we give you this data, how often are you going to use it? And they said, we're going to use it at exactly 9:30 a.m. on Monday mornings, because that is when they have their weekly status update, and that's when they refresh the dashboard. And that was a really powerful insight for us, because it told us we didn't really need to do streaming data for this, did we? We didn't really need high-powered Kafka stream. We would be totally fine with a cron job, with a batch job, because it was only used at a very specific time. We could get it earlier. We could make it available, highly available all of the time, but it actually adds no extra value for the user. So this was a really interesting insight for us. Another question you can ask is, how complete does this data need to be? Right? Some data does need to be 100% complete. If you're sending data to an auditor, to a regulatory, to a legal agency, there might be financial implications. There might be financial and legal costs to missing data, right? FTX demonstrated this very recently, which is very funny. Something else, but not everything does need to be completely complete. Sometimes missing data is fine. If I'm doing a little bit of exploratory data analysis, I might be okay with a few missing records. If I'm picking a random sample to send a one-off marketing campaign to, well, I'm going to be throwing away most of the data anyway, so some missing data might actually be totally fine here. Asking these questions, really working with our users, is key to understanding the need here. We might also ask, how fresh does the data need to be? Some data needs to be real-time. Absolutely real-time. Again, I've worked on real-time alerting systems, right? Monitoring production lines, and they send alarms. Right? If something goes wrong, they sound an alarm. It needs to be real-time. If that data comes in 5 minutes late and the alarm goes off after something has exploded, that's actually worse than useless, because that's adding insult to injury. Some data really does need to be real time, and some data it's fine if it's just within a week or 2 weeks or a couple of months even. Again, if I'm just doing some exploratory data analysis, just getting a feel for the shape of the data, I don't really care how fresh it is. I'm okay with it being a bit out of date. Again, we only get these insights by working with our users. Then we get the really interesting question, right? It's one of my favorite questions to ask. How accurate does the data need to be? This is interesting because everyone always says, well, it needs to be accurate, right? Of course, it needs to be perfectly accurate, or as accurate as it possibly can be. Nobody has ever said, yes, I'd love some inaccurate data, please. Give me some inaccurate data. It's just exactly what I need. And some things do need to be perfectly accurate, or at least as accurate as we possibly can make them. Again, if I'm sending documents to a regulatory agency, putting together a legal report, yeah, I probably do need that data to be pretty accurate. But when people say they need perfectly accurate data, I always like to ask a couple of questions. I ask them, okay, let's say I gave you this data, say I gave you this insight, and it was 1% wrong. It was 1% inaccurate, 1% off the actual correct value. Who dies? Seriously, who dies? They usually say, well, okay, no one's going to die. Okay. So who gets fired? Who loses their job? Or how many millions of dollars do we lose as a business? And then we have a better conversation. Then we actually understand what the real impact of service degradation is. We actually have a much better conversation here. Some data does need to be perfectly accurate, but not all the data does. I'm diabetic. So I've got this little continuous glucose monitor on my arm here. I can hold my phone up here, and it measures my blood sugar. So you can see here it's 9.1 millimoles per liter. And you see it's green, so that's good. That's very nice. Now that's medical data, which I shared live on stream. You're welcome. Now, this is medical data, and I'm going to make medical decisions based on this. I'm going to decide whether or not I should eat food or whether or not I should inject insulin. And if I make the wrong decision, I could die, which would be quite a bad outcome for me, right? Generally, try and avoid that. So you might assume this data needs to be perfectly accurate, but it doesn't. I'm actually fine with this data being a bit inaccurate. I'm fine with this data being 10, 20, maybe even 30% wrong, as long as it's representative. Because as long as I know roughly what range it's in, I'm going to make basically the same decision. You might think that data needs to be perfectly accurate, but it doesn't need to be. In fact, if you talk more with me, you'll understand that an error in one direction is much worse than an error in another direction. If it says that my blood sugar is higher than it actually is, that is generally worse than if it says it's lower than it actually is. That's an interesting insight, isn't it? I got another really interesting insight about this data earlier this year when I went to Greenland for a short trip. I went on a short little hiking trip with some friends, taking some pictures, walking through the ice. It was lovely. Thank you for asking. And I got a really interesting insight. When we got off the plane at Kangerlussuaq, went into the little airport terminal to catch our connecting flight. I did what diabetics do. I measured my blood sugar, brought the app up to my arm, and it crashed. It failed. Did not show anything. I tried again. I restarted my phone, kept crashing. Now, cursed with knowledge, as I am, I turned on the developer settings on my phone, and I found the stack trace. I found the problem that was causing this. I'll give you a second to read that. I'm sure many of you have focused on this line here. You've noticed that there is an illegal argument exception, and the time zone ID of America Nook, Nook is the capital of Greenland, is not recognized. So this particular app did not support being in Greenland, and it crashed. And I was not able to get any data out of it. And that was a huge problem, because I was going hiking. I was going walking in the snow, and knowing what my blood sugar is so I can appropriately manage my blood sugar was a huge impact to me. So it actually turns out the availability of that data is far more important than the accuracy or the freshness of the data. Now, I was able to fix this. I changed my time zone to an equivalent time zone in Brazil, so I did manage to survive in Greenland. But again, you don't get these insights unless you actually work with your users. And there are more questions you can ask, like how durable does this data need to be? Or how consistent does it need to be with some other system of record, perhaps? Or how valid does the data need to be? If we're applying business rules to this, how perfectly do we need to apply those? Or does it need to match a certain schema, a certain format? Once we've asked these questions, we can actually start to form targets for our quality. What quality actually matters to our users? We can write these up as service level objectives if we want. These are service level objectives here. You don't need to write them as service level objectives, but I find it a very helpful way of doing it. We might say, for example, that for one particular system, that 99% of the records should be consistent with some source system X by 9:30 a.m. on weekdays. Or for another system, we want 99.99% of records should be accurately processed within 1 minute of the event occurring. This could be a more real-time, event-driven system here. And we see how we have different goals for different systems because we have different users and different use cases. Understanding that is key. As I said, you don't need to frame these as service level objectives, but I do find this a very helpful way of framing our quality targets. If you want to go a little bit deeper on this, I highly recommend the book Implementing Service Level Objectives. It's got, I think, chapter 11 here is focused on data reliability and some of the metrics and some of the service level objectives we can build here. The examples that I gave actually were pretty simplistic, if I'm going to be honest, and I'm going to highly recommend this talk by my excellent colleague, Emily Gorsensky. It's called A Better SLO for Data Intensive Systems. You can scan the thing there if you want. It looks at how to really construct effective SLOs, really digs quite deep into SLO theory. So if you do want to go deeper there, I highly recommend it. But ultimately, when we get right down to it, there are some real, genuine challenges working with data, working with data quality in particular. We need to deal with the challenge of intermediation. Intermediation and disintermediation is tough. This is one of, I think, the biggest challenges that we have in the data space. If I'm building an application, if I'm building an e-commerce app, I might know actual users who use it. I might see them on the street. That isn't necessarily true for a machine learning model. There's often more layers of intermediation, and we do need to work through those. That's a real challenge that we have here. And if we're moving into the data space, we need to learn new tools and concepts. That's difficult, particularly if you're coming from a software engineering background. You could learn new tools, new concepts, new language. But you know what? That's always true. When have you ever moved to a new project and everything was exactly the same? You didn't have to learn anything new. When has that ever happened? Another problem is we have to deal with the Oracle problem. We don't always know what the expected answer is. And you know what? That's always true. The Oracle problem is one of the older problems in software engineering. So we always need to deal with it. It's front and center here. It's a bigger challenge in many cases, but we always need to deal with the Oracle problem. And we also need to work with domain experts, people who really understand the data, people who understand the implications of selecting one training model over a different training model, or how we use our training and validation and evaluation data sets. We need to collaborate with experts if we want to deliver quality, if we want to build good things. And you know what? That's always true. If we want to build successful quality software, we need to work with people who know the domain. And most importantly of all, if we want to deliver quality software, we need to understand our users' needs. We need to work as closely as possible with our users, understand what impact they are trying to have with our data, with the things that we're building, so we can better meet their needs, so we can better solve their problems. And you know what? That's always been true. Thanks. That's the end. You can, there you go. You can find me on, there you go. That's how you find me. You can follow me for the remaining 2 weeks of Twitter if you so desire. So,
that's a nice outlook. I like you gave it 2 weeks, and no one's quite sure how that's going to end. But great talk, Steve. It was actually really insightful. It was kind of interesting to kind of listen to the feeling that what you're trying to get across. This idea that your needs are very subjective, right? People are trying to give this kind of ironclad idea of what needs to be your constraints, right? You need to be this kind of, I guess the best way I can relate to it is I'm a perfectionist, right? So it's almost like looking at data as a perfectionist element. I guess one question I pose to you, how difficult is it to kind of get people to come across this thought process, right? Because I used to be a developer. I was in those type of environments, and I know from that side alone, people are stubborn. They like what they know.
Yeah. Yeah, absolutely. What we know is comfortable, right? We kind of retreat to that, like, yes, I'm going to keep doing the thing that I know that I've been doing for years. I know how that works. That's a nice, comfortable thing. I think there's two angles. Two angles you can approach this. First is taking people out to talk with the users. I took a data product owner a little while ago out to talk with one of their users, and they got in a 30-minute talk, going through some of the questions that we talked about. They got insights that they had never seen before. They had never gotten those insights, and they were on the edge of their seat. Their mind sort of watched this light bulb moment happen in their head. It was really, really beautiful, because they understood, like, oh, there's a person over here, right? Prior to that, they'd been thinking in terms of data and processing and getting it into the right place. Just going and talking to people is I think both an incredibly important thing and just an incredibly rewarding thing to do, to actually see and understand the impact you're having. And then the other thing from the kind of engineering side, there's an opportunity cost to perfectionism, right?
Yeah.
If my data is only needed once a month at 9:30 a.m. on the first Monday of every month, I could build a streaming data solution with PySpark and Kafka and all of these things tied together. But honestly, I might just be fine with a cron job, and I could be putting my time and my engineering effort into things that actually impact our users. So this is something that comes from SLO theory, is that there's an opportunity cost to doing things that your users don't care about. So.
Okay, and we've got some answers come through. Remember, folks, use the Q&A section while we do have Steve still here. I got a question in from Mirko De Martino. They ask, can you advise on state-of-the-art data profiling tools? Is Great Expectations the one to go for? I think they are referring to books potentially there.
Yeah. I'm a big Great Expectations fan. I have used, I briefly used DQ in the past. I'm going to be honest, I am not the best person to talk to about. See, when it comes to libraries and frameworks, I tend not to be too concerned with the details. I'm like, okay, does this solve my problem? Yes, I have the controversial opinion that all testing libraries are basically the same. They're just slight variations on each other. So if you can make one of them work, you can probably make the others work. Like I said, I'm a big fan of Great Expectations. I think it's got a very good approach to visualizing and profiling data. DQ I've used in the past. It's another one I have to remember. If I remember, I'll post it in the chat, I promise.
Okay. And we also got a question coming in from Akash. They asked, do you recommend property-based unit testing over example-based for all big data use cases?
Ooh, no, I would not. No, I think there's a place for both, right? So example-based unit testing, it is great for very constrained contexts, right? I have a small thing that I am testing, a particular function, a library, a method. I want to build confidence that it works in the way that I expect, right? Remember, those unit tests are about supporting me as a developer, me as an engineer, letting me know that I didn't break something with that last line of code. And honestly, just writing a short example, like if you've got a function with one argument, you can probably, or a handful of arguments, you can probably just create an example for that. Property-based testing can also make sense. Property-based testing makes sense as our constraints get larger and more flexible, right? So think about it. It's not about one or the other, but like, where are they appropriate? Example-based unit testing is better for more constrained cases, and property-based or data profiling approach is better for larger scale cases. Always, you're going to need a little bit of both.
Yeah. Okay. And one thing I was kind of thinking of as quite interested in that point you had around, you being a diabetic, you having certain apps to kind of track that, and how they don't have to necessarily be accurate. Is that that kind of surprised me? Like, is that something specific to that app, or was that an example? Because I feel like there's a lot of those type of situations where there's a legal constraint that requires them to be overly accurate, right?
Yes. So this was my kind of specific example. It's like I'm
Okay.
fine if that's a bit off. I will say, I mean, shout out to the app that I use. I actually think it's pretty great and it's really helped me. When I first got it, they sent me an email, and there's obviously a big legal thing you've got to say, yeah, terms of service, right? The interesting thing is if you actually dug into it, it gave the error bars for their results. So it said like,
Okay.
okay, we're going to be, within 97% or 98% of a certain control, blah, blah, blah. It was a long kind of legal medical text, right? Their accuracy is probably more accurate than I realistically need it to be
Okay.
very honest. I would probably rather have it be more accurate than more inaccurate, but it was more me trying to make the point here that
Getcha.
my actual needs are a little bit different from maybe what you might perceive. And the only way you're going to understand that
I
is by
see.
engaging with the user.
Yeah, I guess what I was leading into is that's the kind of element of business, right? Like where you can kind of make those savings is sometimes there's probably businesses that can reassess what they are putting on themselves as stresses, right?
Yeah.
Constraints that they have to abide by. Obviously, medical things quite strict, but definitely a lot of industries where they can be a bit looser.
Yes. Yes. Yeah. Exactly. I've worked in the medical in the life sciences industries, let's
Hmm.
say. And yes, there are real constraints that you've got to very very fixed constraints that you need to abide by. And at the same time, you should also question those constraints. Really, genuinely try and understand what are they really trying to accomplish here. What is the like? Okay, there is a huge. I'm sure again, if you're building a medical device like this one, there is a huge pile of legal regulatory documents you need to get through. Take the time to read them and understand what they're actually trying to achieve here, right?
Yeah.
Understand the why behind it, and that's going to give you I think push you in a good direction. Let's say.
Yeah, the non-pig-headed approach, right? They just
Yeah,
always
yeah.
question, always look
Question.
for
Yeah,
the whys. I love
yeah,
that
yeah,
approach.
yeah.
But I think that is all the questions we have. I won't keep you too much longer. Thank you, Steve. It's been an absolute pleasure to have you. Is there anywhere people can contact you if they've got any follow-up questions and whatnot?
I'm going to try and hang out in the chat for a little bit. I'll be around. I've had my various contact details up on the screen for a bit. You can find me on Twitter, LinkedIn. You can email me. Go wild. I'll be entirely unavailable for all of December, but otherwise, yeah, just send me a message. I'll do my best.
Fantastic. All right. Well,
Cool.
we're going to close this one out. We're going to go a short break, and then next up, we'll have our next speaker. But thank you, Steve. Absolute pleasure.
Ciao, folks.
All right, stay tuned because when we come back, we're going to have another talk in just a few minutes. Going to be talking in regards to Postgre, SQL, and a bunch of other interesting subjects. You don't want to miss it.